Hello everyone. In this video, we'll look into the next topic, that is laws of motion. And in this topic, we'll be looking into Newton's laws of motion and impulse. Now, what are the Newton's laws of motion? There are three laws. We have been studying these laws right from 7th or 8th class. So let's again quickly have a review about these laws. Now, what does the first law say? The first law says an object remains in state of rest or uniform motion in a straight line until and unless an external unbalanced force acts on it. Now, there are two terms which might be of interest where people get confused. One is what? Unbalanced force. Now, what is unbalanced force? A force where if there are more than one forces acting on the system, and if the resultant is not zero, then the forces are called unbalanced. Then what is external force? Now, once I consider a system, then any force applied by the system or on the system is external force, right? So what does first law say? It says an object remains in a state of rest or uniform motion in a straight line until and unless an external unbalanced force acts on it. This law is also known as law of inertia. Now, what is this inertia? Inertia is tendency of a body to resist any change in its state of rest or uniform motion. So, because inertia is opposition to change. Now, in first law also we say that the object which is at rest remains at rest. It opposes any change. That's why this law is called law of inertia. Now, let's look at a couple of examples of inertia. Now you can see that there are lemons and a cardboard placed on a couple of four glasses. Now when the cardboard is quickly pushed off, the lemon fall onto the glasses. Now why is it happening? The cardboard moves, but the lemons do not move. Why they are not moving with the cardboard? Because they have inertia of rest. So due to inertia of rest, what is happening? They are still staying at the same point. Now let's look at this position. A person moving on a trolley, the trolley hits a block and stops, but the person falls down. Now why the person is falling down? When the trolley is moving, the person is also moving with the trolley, but when the trolley is stopped, the person is still moving and hence he falls down. This is an example of inertia of motion. Now let's look at Newton's second law. Now what does Newton's second law say? Newton's second law says the rate of change of momentum of an object is directly proportional to the applied unbalanced force, and it takes place in the direction of unbalanced force. So let's try to write it in the form of an equation. I can say F equal to dp by dt. Now what is P? P is momentum. So actually it is F is proportional to dp by dt, because proportionality constant is 1. I can write F equal to dp by dt. Now let me do it. I write P as mv, then F will be equal to d by dt of mv. This can be written as F equal to dm by dt into v plus m into dv by dt. I have used UV rule to differentiate it. Now, or I can write F equal to v dm by dt plus m dv by dt is what? Acceleration. Now, what is dm by dt? Dm by dt is rate of change in mass. So, if mass is constant, then what would happen? Then dm by dt would be equal to 0, and then we'll come to the famous relation that we have been remembering, F equal to ma. So again, F equal to ma is not the second law. What is second law? Second law is F is proportional to dp by dt. Now F equal to ma happens to be the one of the conditions of second law, or one of the special cases of second law, where the mass of the system remains constant. Hope you could follow this. So let's go further in this. Now what is momentum? Momentum is product of mass and velocity. So momentum is given by P equal to m into v. That's what it is written. Now v is a vector quantity and m is scalar. So scalar multiple of mass and velocity gives us momentum. So momentum is also a vector quantity. What is the direction of momentum? It is directed along the direction of velocity. So momentum is directed along the direction of velocity. Now why we study about this momentum, that is product of mass and velocity? Because whenever a force is applied, what does the force do? Force tries to change the momentum of the body, not only velocity or mass. It can change either mass or velocity or both together. So that whole can be considered as momentum. The next concept that we look into is impulse. Now what is this impulse? If a large force acts on for a small time on a body, then the impulse is imparted is given by the product of force and time. So what is impulse? Impulse is product of force and time. Now if impulse is product of force and time, it is equivalent to change in momentum also. So I can say impulse is what? It is effect of force. Now what does the force do? Force changes momentum. So I can find impulse by, if force is constant, I can find the product of F and T. And if force is not constant, it is a function of time, I can write integral F dt from T1 to T2, the interval in which I want to find momentum. And if I know what is final velocity and initial velocity, then I can say impulse equal to change in momentum, that is equal to m into v minus u. Now let's look at a small example. Let's say an object is moving with a velocity of some 20 meter per second. It hits a surface at an angle of 60 degrees. Then it is again reflected with the same speed 20 meter per second at 60 degrees. Now find the impulse of the ball. What is the impulse of the ball? Because I know final momentum and initial momentum, I need to find change in momentum. Now you can see that momentum is only changing along x-axis. So I'll find the components of this. So if this is u, this would be u cos theta. Similarly, if this is v, this is theta, right? This would be how much? V cos theta. So I can say change in momentum is minus v cos theta minus of u cos theta. Why minus? Because final direction is opposite to initial direction. So impulse of the body which is striking the wall is how much? It is minus v cos theta minus 20 cos 60 minus 20 cos 60. So how much will that be equal to? So twice, that is minus 40 cos 60 is 1 by 2, that is minus 20 Newton second. So in this way we can find impulse. Now if they want, if force is asked, then they'll give you time. Then average force would be equal to how much? Impulse by time. So that is equal to delta P by T. So in this way we can find average force also. Now there are other ways of finding impulse. Now the other ways of finding impulse is, like as I just told you, if force is given as a function of time, let's say force is given as t plus 1. I want to find impulse in the first 2 seconds. I want to find impulse in first 2 seconds. So how do we find impulse in first 2 seconds? I can write I equal to integral 0 to 2 f dt. So how much will that be equal to? I equal to integral 0 to 2 t plus 1 into dt. So that becomes t square by 2 plus t from 0 to 2. So how much is that? So 4 by 2 is 2 plus 2, that is 4 Newton second. Impulse due to this force in the first 2 seconds is 4 Newton per second. The other way is graphical method. If I have a graph of f and t, so something like this, the area under the graph will give us impulse. So I can say the other way of finding impulse is area under ft graph. So these are the three ways in which we can find impulse, area under, let's say, ft graph. Right. Yeah. So this is about impulse. So impulse is what? It is the effect of force, and we have seen what are the various ways in which we can find impulse. Then we have Newton's third law. What does Newton's third law say? Every action has equal and opposite reaction. And very important thing, action and reaction always act on different bodies. They do not act on a single body. So I'll take an example of a book lying on a table. Let's say there is a table, I have a book lying on it. Now book pushes the table with a force which is equal to weight, and the table pushes the book with a force which is called normal reaction. So this normal reaction and weight are action reaction pairs. The weight of the book is acting on table, and normal reaction of the table is acting on book. So we can see that action and reaction always act on different bodies. So this is what is there in Newton's laws, like basic definitions of Newton's laws. We have just had a quick relook of what are the three Newton's laws, and then we defined what is momentum and impulse. So thank you very much, and the remaining topics we'll see in the next videos.